Thank you, Lars. Yeah, well, hi everyone. I hope you are fine today. And yeah, my name is Tim. I'm from CLOUDETEER, and I just would like to give you just a quick overview about who we are and what we do. We are a cloud native tech company with locations in Hamburg, Bremen, and Munich, and we consist of cloud enthusiasts like SREs, cloud consultants, and Kubernetes experts. And so what we do basically is we provide our customers with holistic multi-cloud consultancy and managed cloud services. And yeah, so far at this point, this shall be everything as an introduction. So for further information can be found on our website. And so what I would like to hand over back to you. Thank you.
Okay, thank you so much, Tim. Now, Sunny, I think the ball is in your box now, and please show us your magic.
Thank you, everyone. So I'm Sunny. I'm from CLOUDETEER Site Reliability team. So in this session today, I will be providing a Terraform demo on multi-cloud deployments, basically on AWS and Azure platform. So I will do it parallelly so that we don't overstretch our duration. And as like Lars and what said, in between, if you have any questions, please put them in the chat, and we will take over whenever we have the time. So I would like to first start with my directory structure. So just a sec, I will start sharing the content. Okay, so I hope everyone is able to see my screen.
Yes, we are.
Okay, thank you. So let me just first start with the directory structure, how we have it currently in my local system. So yeah, as usual, I'm using Visual Studio Code as an editor for my local development, and we usually use Azure DevOps in the background, like basically for running the pipelines. So these are basically the tool sets we use. And in the current scenario, I have two folders, AWS and Azure. And in Azure, we will use our own custom modules to do the deployment. And in AWS, we will mostly start using the modules which have been provided over Terraform registry. So you will see how we could use custom modules. You could also see how we use the modules over the registry as well. Okay. Are you guys able to see my video?
Yes, we are.
Yes.
Okay. Okay. Thank you. Okay. So as I think most of the guys are aware, like what Terraform is, like what Terraform does. So I will not go into the basics, but in between I will touch base the best practices of Terraform, which we have been using for our customers, like in the production systems. So it's very important that we have a remote storage for the Terraform. So like if you see my current configuration in Azure, I have a backend configuration here. So basically we are using a remote storage account to save our Terraform state basically. And we have a container and inside that we save our Terraform state. So it's really important that you always have a remote storage, not a local state, because then if you are working as a team, then it's not possible to work with Terraform on your local systems. So, and in AWS, we are using S3 bucket, and we use DynamoDB table to do the state locking. So why we do the state locking? It's also a part of best practice that if you are running your pipelines, in case somebody else also triggers the pipeline, if you have the locking in place, then there is a lock already created on your state file, and the person who has triggered a Terraform apply or execution, he will not be able to acquire the lock, and he will not be able to do any Terraform executions. So these are the backends we will use for AWS and Azure. And then let's come to the providers. So here we have defined what provider versions we want to use. And if you see for the Azure, I have defined what sort of version I want to use. It is sort of, again, a best practice that you define what sort of version you want to use. You don't say, okay, by default, I want to use latest, because it is possible that whenever there are some new versions released from HashiCorp, that they might have some breaking changes which ultimately break your system. So please always have a particular version added in your Terraform provider configuration, and then you can also mention, okay, what sort of Terraform version you want to use. So here we are using 0.13 Terraform version, and same we have in AWS as well. So we have the same configuration, similar sort of configuration present for AWS. So in terms of the syntax, or in terms of the configuration, nothing changes when you are deploying it on multi-cloud platforms. So then it becomes easy for you if you use a tool like Terraform, that you can create resources on AWS or on Azure, because you know the tool, you know how it works. And suppose somebody says, okay, I don't want to use Terraform, I am using like AWS CloudFormation, and somebody says I'm using Azure ARM templates to do Azure deployments, then you always have to learn those tools as well, and then it just adds the complexity. So if you are like a multi-cloud company, or you are a person who works with the multiple cloud platforms, so it always makes sense to have a tool which you can use across multiple platforms, because then it increases your efficiency and it brings consistency in your tool set. So that's the reason why we have chosen Terraform to do our infrastructure deployments in AWS and Azure. It's not like that CloudFormation or ARM template, they are not good, but in their own space, they are good and they are well suited to do the deployments. But if you see the larger picture, and if you have to maintain multi-cloud systems, it's always best to have a tool like Terraform, which you can use across all your platforms. Okay, so in Azure platform, currently I have already configured storage account name, container name in my session. So all this code will be available in GitHub. So at the end of the session, we will provide you all the code, and you can play around with that. And if you have any questions, you could also come back to us. So let's first start with Terraform init. So I will just also brief what Terraform init does. So it basically initializes all of your modules. It initializes the backend, and it also downloads all the necessary plugins. So if you could see here, like Terraform init, what it did is that it initialized all the modules. It initialized my backend, so it knows I'm using a remote backend, and then it also downloaded all the necessary plugins which have been defined in this particular file. So this is the part of the Terraform init. So next we will run Terraform Validate. So what Terraform Validate does is that it validates your configuration. So it says, okay, whether your configuration is valid or not. So once we have configuration is valid, we can move to next step, Terraform plan. So Terraform plan does a couple of things in the backend. So there is something called as Terraform refresh. So Terraform plan does a refresh to the state file, and it also does a reconciliation of the current configuration which you have in your code and the real-time infrastructure which you have created through Terraform. So suppose you created some virtual machine and then somebody deleted that virtual machine in the portal. And next time, if you run Terraform plan and that virtual machine is still in your configuration, then it would say, okay, I want to create this virtual machine again, because it was able to do the reconciliation with the real-time infrastructure and what configuration you have, and it updated the state accordingly. So that's the job of the Terraform plan, and it tells you what resources it wants to create. So in Azure right now, in this particular demo, we will create a resource group. We will create a virtual network, and we will have a couple of subnets in which we will create our AKS cluster, which is basically a managed Kubernetes cluster provided by Azure. And we will also create a Bastion host, and this Bastion host could be used to access the worker nodes of the AKS. So just to start with, I will just comment out AKS cluster. As of now, we will just create the VNet resource group and Bastion host, because I just want to create these Kubernetes cluster in Azure and AWS parallelly. So first, let's go through the base deployments in Azure. So to run this Terraform plan, we can say Terraform apply auto approve. So here auto approve means I don't need to provide a manual input. So if you just run Terraform apply, it usually says at the end, do you want to run this? Then you can say yes or no. So let's run this. So if you could see, it says acquiring state lock. So this is what I was talking about, that it will always try to get a lock on your resources, on the Terraform state file, and then start creating the resources. And let's quickly go to AWS as well. So like here we could again start with Terraform init. So it does the same thing. It initializes the module, it initializes the backend, and in case you don't specify your backend configuration correctly, then usually your Terraform init command will not work out and you will have some errors. Now there is something unique in AWS backend which I have done here. So if you see, I have specified a bucket name here. I have specified a DynamoDB table. And these two resources I have created with this setup.tf file, where I'm defining the resource block for S3 bucket. And I'm also creating a DynamoDB table. And the S3 bucket and the DynamoDB table, they were created before I mentioned them in my backend configuration file. So I first ran setup.tf file, which created S3 bucket and DynamoDB table for me, and that state was in my local system. So that was not remotely. And once I had these S3 bucket and a DynamoDB table created, I provided this information in my backend configuration, and I added a particular flag, prevent destroy lifecycle, prevent destroy equal to true, which basically means that if I'm running Terraform destroy, it will not be able to destroy these resources. So if you want to make sure that you want to use Terraform for creating the remote backend resources for you, then you could use this method, that first you define S3 bucket, DynamoDB table configuration in your Terraform code. You run it locally, it creates these resources for you, and then in the backend.tf, you add this particular configuration, and then once you again run Terraform in it, it will say that your remote backend configuration has come into picture. Do you want to migrate your state from local to remote S3 bucket? You say yes, and then all your state is migrated to S3 bucket. So this is one way that you can create the backend resources for your Terraform, or it's like you can have a script which already creates these resources, and then you can directly mention in your backend. So it really depends upon you how you want to create the backend resources for you. Like in Azure, I ran a script which created storage account and container for me, and then I just simply mentioned that in my backend. So it's just that I just want to show you that there are different methods which you can use to define your configuration for your Terraform state. Okay, so then let's proceed with Terraform Validate for AWS. So in AWS, we will create a VPC with private public subnets, and we will use a Terraform registry module, VPC module. We define here what sort of version we want to use. So basically, these sort of modules are provided in the Terraform registry. These are the verified AWS modules. And if these sort of modules directly fit your needs and you don't need to do any customizations, then straight away you could use these modules and save a lot of your time. But in most of the cases, there might be a scenario or a situation where these modules don't fit to your needs. So you might have to write your custom modules. So you could do that as well. So like here in Azure, all the modules have our custom modules which we have written. So we just want you to show both of the flavors, that you can write your custom modules, and you could use registry modules as well provided by Terraform. So and we have here EKS module, which basically will create an EKS cluster. And we have defined, okay, we need T3.large instance size. EKS cluster will be behind an auto-scaling group. So we will define here what's the desired capacity or max size. And one important thing here is that we are trying to use the module dependencies, you can say indirect dependencies here. So suppose I have a VPC module. So I get here outputs like private subnet IDs or public subnet IDs. So those dependencies I could define here. We take the outputs from these modules. So like here I say, okay, subnets, I want to use module.vpc private subnets, and same for the VPC ID. So in a way, Terraform will know, okay, first I need to create, first I will create VPC, and then this EKS cluster is dependent on this VPC module. So this is sort of like an indirect dependency. But with Terraform 0.13, you could also say, okay, one module depends upon another module. So that's up to you how you want to define the dependencies in the Terraform modules. So for AWS, let's first just create a VPC. So I will just comment it out, EKS cluster. We will create it later on with AKS. So let's run Terraform plan for AWS. So this usually this bastion host in Azure, it takes some time. So yeah, now it is done. So all the resources in Azure which we had defined in our configuration have been created. So we have 6 resources created. So we, if you want to display what resources have been created, so you could always define them in your output. So like here in our output, we have defined we want to display output of the resource group. Now, one important thing here is that suppose here we are just saying resource groups, but suppose if you have another resource like where you want to show in the output, maybe you want to use the output of a module like some DB username or password, but you don't want to show that on your screen, or you don't want to display them, then you could use something called as sensitive equal to true. So let me just show you. Like you could define it here, like sensitive equal to true. Then in next apply, whenever you are doing the apply, you will not be able to see the output on your screen, but you will be still able to refer this output in your Terraform modules. Let me quickly run this. Terraform apply auto approve. So this will create the base resource for our EKS cluster in AWS. Okay. And one important thing is that when you create your custom modules, so like suppose we go through AKS module, so as a part of best practice, we should not hard code any of the values. So like just giving one example here. So suppose we have this VM size here. So suppose instead of using a variable, you say, okay, I put it here something like DS2 V2, something like this. And then in case somebody from your team is calling this module and he wants to override this, then he won't be able to override these particular parameters or variables. So you have to always make sure that whenever you are writing your own custom modules, please add as many variables as possible. And that really helps when you are using these sort of modules across various environments for various customers. And here we are using dynamic blocks. We have defined for each. So like in AKS cluster, we said, okay, if we don't have a client ID or a client secret, then please use system assigned identity. So there is a lot of possibilities with the newer versions of Terraform. Starting from Terraform 0.12, you could use for each dynamic blocks. Before that, we had just count. So you can try to use these for each in your code. It really helps, as if we really compare with the count, because suppose you created 2-3 resources with count and then you have to delete or move any of the resources, then count is really problematic and it causes a lot of issues. So our AWS VPC resources are also created. So now we have the base resource created both for AWS and Azure. If anyone has any questions, he can ask. Or Word and Lars, do you have any questions till now?
Yes, we actually have one question. Simeon asked, like, how is it possible with Terraform to manage databases in Azure as well as in AWS? And he brings up the examples of Azure Cosmos DB and AWS DynamoDB.
Yes, we can.
Simeon.
Yeah,
Sorry.
we can manage all these resources. We have an active community present for AWS and Azure in terms of the Terraform developers, and we have mostly all the modules available in Terraform registry, or we have the resource configurations available for all the services which is available in AWS and Azure. So you can create almost all resources in AWS and Azure, be it database, be it firewall, like anything, you can create it. And suppose there is a service or there is an action which you are not able to perform directly with Terraform, there is an option that you also could use null resources in Terraform, which internally you can call some PowerShell commands, you can call some Azure CLI commands, or you can call some AWS CLI commands, or you can call some bash script and still do the magic with Terraform.
Okay, there is a follow-up question. Basically, Simeon is asking if there is also a cloud native approach to this. Simeon, please, if you feel comfortable, you can also unmute yourself at this point and maybe give more details to this question, if you will.
Yeah, like, OpenShift or some of the other things that they try to do the same thing, but they have Cloud Foundry for this, but I haven't noticed anything like this. AWS with Azure together in a resources that's managing.
Sorry, I honestly didn't get your question still. So what really you are asking? Could you please repeat once more?
Okay, so is there any cloud native or serverless approach to both of them? Is there an API to both of them that you can call it into Terraform interface somewhere, like in an application, for example?
Mm-hmm. So you are trying to ask like if there is some approach where you want to create resources both in AWS and
Azure.
Azure.
Yeah, in a cloud native form where you can call it as an API.
Okay. I don't know any of this till now.
Okay.
So,
Sorry.
So because we as of now we just see that it's the Terraform which you could use, but there might be some tools coming up which you can directly use in the cloud native approach to directly create resources there. But as of now, I don't know any of such tools currently.
Okay, this is brilliant, by the way. Thank you.
Thank you. Okay, so let's now proceed towards the Kubernetes clusters. So as of now, I have just uncommented my AKS cluster code and EKS cluster as well. So let's first start with the AKS. So I will just run quickly Terraform plan. So usually the Kubernetes cluster in Azure, it just takes max to max 5 minutes to provision it. And in AWS, this EKS cluster is a bit slow. It takes around 10 to 12 minutes. So I will quickly run them. Terraform. And now here in AWS, I just want to show you something. So suppose if I now run Terraform plan, mostly it might error out. And I will tell you the reason why it will error out. Okay, so this time it didn't. But in case what happened, you specify here, okay, I want to use this particular module. And if before that you had some Terraform initialization, you did some Terraform initialization and you didn't fetch this module before that, then most probably when you do the Terraform plan, it will complain that it doesn't know about this particular module. So for us currently, the Terraform init already took care of this, and I don't have any issues with Terraform plan. So I will quickly this. And one more thing to add here, in case suppose you want to also add like other stuff in your Kubernetes cluster, like you want to add HashiCorp Vault, or you want to include Helm in your Kubernetes, then Terraform also has providers for that. So you could also add uh, Vault provider or Helm provider, and then you can add them to your cluster by using Terraform. But for this session currently, I'm not doing that. So I just want to keep it simple, but I just wanted to mention it that there is a lot more which could be achieved with Terraform. This is not just the end of the world. You can do a lot of automation with Terraform, because Terraform has been continuously developing a lot of providers which you could use in your Terraform configuration to do all the resource deployments. So currently EKS cluster is getting created. This mostly will take around 8 to 9 minutes, and Azure Kubernetes cluster is also getting created side by side. So to provision these clusters with Terraform, it's a pretty fast way. Just imagine if you do it via portal, it's a bit of a pain that you have to always go to various resources, do IAM roles, or create resource groups, or take care of all the configurations. So when you use Terraform, you have the same configuration for your resources, and you can create them, you can destroy them whenever you want. So like a typical scenario is like if you have like a dev environment, and your development teams work on Monday and they finish their work on Friday every week. So you could have automated pipelines which create resources for you on Monday morning, and then on Friday evening you just have the pipelines which again just destroy all of your resources. So this is and this, I can say, benefit of using Terraform is that you can do whatever you want with your infrastructure at any point of time, and helps you to have a consistent infrastructure across all your environments. So if you want to have like a production scale deployments in your environments, so make sure that you have usage of the modules. You always try to use modules across all of your environments. So suppose right now I have a dev environment, and suppose tomorrow I have production, pre-prod, or UAT. The only thing which is gonna change is the variables, the values, what I'm passing. So like here, suppose I'm creating bastion hosts. So at the max, what will change is the network or resource group, but the main code which has been defined in the modules remains same. So your configuration will always remain same. So that's why we always encourage people to use modules. So you could always call all of these modules in your different environment state, and just have different configuration files. That's it. And when and also as part of best practices, what you could do is that if you have different environments which you are managing through Terraform, always make sure that you have different storage accounts or different S3 buckets for these environments, and you don't just use a single storage account or S3 bucket. Okay, so it seems our AKS cluster has been created. So it was just created in 4 minutes, which was pretty fast. And we still have EKS cluster, which is still running. So yeah, if anyone has any questions, please ask. So Lars and Vad, do you have any questions?
Yes, we have 2 more questions. I hope I don't butcher this. Murugavel asked, for example, for an AWS EKS Fargate setup. He wants to know if it's possible with Terraform to set up an ALB ingress controller for internal load balancing. And he wants to know if this, for example, needs any additional security privileges to set up.
So again, this is more related to the resource configuration. I would say you can obviously create a EKS Fargate resource with that. So like if you right now said, okay, I want to know whether I can create an internal load balance ingress for that. So if you want to know whether it is possible right now with Terraform, so you always can go to the Terraform registry and check for the modules if there is any. If not, then you can directly go to the Terraform documentation where they document all the resources which can be created. So if it is possible to do with the Terraform, you will find it how to do it. It also, like this question, I will say it's more specific to the way the AWS Fargate works, because I know that with AWS Fargate, there are still a lot of limitations which AWS has planned a roadmap in the coming days. So if you can do a resource creation through CLI or through Portal, then it is possible to do it through Terraform as well. So this would be my answer for this.
Thank you, Sunny, for clarifying that information. Because currently we are struggling with a forgot for file in the internal load balancer. So we are trying with the command line options. Some security privileges are popped up. That's the reason we want to check whether Terraform any ready-made available scripts to execute to create the load balancer, internal load balancer.
Mm-hmm. Yeah, so like as you said, like you are using some CLI commands. So what you could do is that you can even wrap those commands in the Terraform through null resources or through some local exec and run them. So that would also help you to automate the resource creation. And as you said, you still have some issues with like some security roles or groups, then it's more specific the way you are trying to create the resource. That will not be specific to Terraform.
Okay. Yeah. So we are trying with the enterprise level. That's the reason a lot of restrictions are there in the security perspective.
Mm-hmm. Yeah, I understand what you are trying to say.
Yeah.
Yes. So that is totally dependent upon the design and the architecture which you have. So like suppose as of now we created a Kubernetes cluster, and this Kubernetes cluster has a public endpoint, and I might have restrictions in my organization and saying you cannot create it as a public endpoint, you need to have a private endpoint. So like then I might have to change my configuration and I go to private cluster. So in case I go to a private cluster like in Azure, I might have to define my own custom user-defined routing. So I might need to have a firewall. I might need to create some routes to push all the traffic from subnet to the firewall. So all these scenarios depend upon the way you have the policies defined in your account or in your subscription. But most of the scenarios are able to be done with Terraform.
Okay. Yeah. Do you have any kind of sample Terraform projects for the organization level EKS cluster setup? Is it in a private subnet, not in the public subnet? Private subnet with the EKS cluster?
So like right now, the EKS cluster, if you see where it is. So subnet, it is in the private subnet right now. So whatever EKS cluster we have created, it's in the private subnet. So if you refer to the documentation of the EKS cluster, you will see they are like for the production system, they clearly say that you need to have public subnets, you need to have private subnets. So public subnets are required for having your load balancers, and private subnets you can use for your worker nodes. So all of your worker nodes will be in the private subnet. And then you have the NAT gateways created in your VPCs, which could be used by these private subnets to talk to the internet. And in case you don't want to have any public IPs, any public endpoints, then it is also possible in EKS that you totally create a private cluster.
Okay. Yeah, that's the approach only we are struggling right now, honestly, if you want to say. That's the reason maybe if any help required, we'll connect with you offline. Yeah.
Okay.
Thank you, Sunny and teams for, yeah.
Okay, thank you. So if you could see right now, still EKS cluster is creating, so it will still take 2-3 minutes more to complete. But I think Lars and Bud, we could move towards Q&A section.
Yeah, this is a quick question. Just Stephen asked, like, if we see a lot of GCP setups currently, or if this is still only popular in the US. Patrick himself already gave his view on this in the chat, but maybe you can also share your views on this.
Yeah, so in my view, all these three cloud platforms, AWS, Azure, and GCP, these are the most widely used platforms. So you could also use Terraform for GCP as well. It's just that to show all these three public cloud platforms in one session, it requires more time. So that's why I haven't included GCP in my demo currently, but it's nothing like that. GCP is not a force to reckon. So we see a lot of Kubernetes cluster being also created in GCP platform. So the GKE clusters are quite popular as well, and you could use Terraform to create GKE clusters as well. So yeah, Terraform can be used on all these public cloud platforms to do whatever you want to do. Do we have any more questions?
No, that's it for now for questions in chat. If anyone else maybe has a question, please let us know.
Sunny, I have joined a little bit late. Can you please elaborate what are the base structure required for executing in the Terraform project?
Okay, so like if this is so suppose this I have created AWS and Azure directories here, okay, and inside each of the folders I have an environment folder here, okay. So like suppose I say it is Azure environment /dev. So here I have a dev environment. I could also have a prod environment. I could have a UAT environment. And then what will differ in all these environments is that I will have a different, mostly a different backend configuration. So I will have a different storage account or a different S3 bucket in AWS. And then if you are creating like the same set of resources in different environments, so what will differ is just the configuration, just the parameters you pass on to your modules, but the modules should be same. So you don't change modules for your dev environment, for your UAT environment. You use the same modules across all your environments, and you just provide different input parameters to these modules in different environments. So this helps you to bring the same configuration, and it helps you to avoid any inconsistency across any of your environments. So this is sort of a base structure you can have for your Terraform.
Okay, it's basically an environment folder and the modules folder and some global files, right?
Yes.
Bastion backend is all global files.
Yes. So we define, you have a providers file where you define all your versions, what you want to use. You have variables file where you define what variables you want to use, what outputs you want to show, that you can define, and you have backend file, and then rest all are your resource creation files like resource group or bastion host, whatever, and you can carry out the same structure for all of your environments. Yeah.
Go to the development environment folder. Any files are there in the environment dev?
Yeah, this everything is in dev folder. So if you see, so if you see here my screen,
there is Azure.
so everything is in
Okay.
dev folder. So all of these
Okay.
files, all the configuration files are in dev folder.
Okay.
Yeah.
So if basically if your Terraform
interrupt.
execute event, it take the main file, right?
Mm-hmm. So
Sorry, but Mugabe,
like,
please, I would please for now say we continue, and any further questions we should now keep for later on for the Q&A, please.
Sure.
Yeah. Okay. Yeah. Yes. Yeah. Thank you.
So just want to say that our EKS cluster is also created. So we have now both Kubernetes cluster in AWS and Azure. Yeah, so this is basically it from my side. So this was a quick demo, like how you could use Terraform in multi-cloud platform to create the resources. And I included Kubernetes because nowadays everyone is using containers. So that's why we have included Kubernetes cluster also in our demo. And we also have a README file in our GitHub, which will provide you links to various Terraform documentations, configurations. So you can also go through that. And if you have any questions which we could not answer right away here, you can also contact us, and we would be really happy to help you. So I will now pass it over to Lars and Bud.
Okay, could you please open the...
Yeah.
Okay, then for all of you guys, a few more links. As you see, the link to our meetup group, and also if you're interested, we have a technical blog on our website. And I already posted this link in chat, but here it is again, where the code for this meetup event resides. Feel free to have looks. If you see anything wrong with it and have suggestions or improvements, please just go ahead and create a pull request. We are happy to review it and integrate it into our code. Yes, I guess then, do you have anything else, Sunny, or should we now go over to the Q&A?
Yeah, I think that's it from my side, yeah. And maybe I would just like to add that if you have any suggestions that you would like to see in our future meetup groups, like any particular topic, so you could also provide us suggestions in our meetup group. You can write to us, and yeah, we will be happy to take your suggestions and improve in future. Yeah.
Sunny, maybe you could show us our resources that we actually deployed. Maybe this could also be interesting.
Okay. Let me just refresh my sessions here. So. Yeah. So this is our EKS cluster, which was created. So we had created all our resources in the EU Central region, and we will have the EC2 machines, which are basically our worker nodes, which communicate with this EKS cluster. So you could see all of them are running, and they have passed all the status checks, so everything is fine. I could also quickly go to Azure. Let me just go to Kubernetes services. So this was our Kubernetes cluster, which was created, and we could go to the properties. You will find the infrastructure resource group here. Just to mention here, we had provided a custom name for the infrastructure resource group. And yeah, inside this, we had all of our resources created. So we used virtual machine scale set in Azure. Yeah, we have the managed identity, route table, energy, all the resources inside this. Yeah. Okay, so I think we are almost finished with our time schedule. So yeah, thank you everyone for joining, and it was our first meetup session, so we are really thankful that you all joined, and we hope to see you in near future as well in our meetup events. And if you have any suggestions or improvements for us, please feel free to point it out to us. Thanks a lot.
Yes, sorry. Also, sorry to Murugavel. I must have misread this. As Sunny said, this is our first time. I thought we had some more stuff, but as we can now go over to our Q&A, please just continue with your questions if you still have any.
Yeah, thank you, Lars and Sunny. First of all, it's a very interesting for us. So for the reason we asked for a couple of questions. Definitely, it is helpful for us.
Thank you. Last, do we have any questions in the chat?
We don't have any in the chat right now. Feel free to, if anyone still has questions, just feel free to ask them right now.
Okay, and one more last question from me, if you don't mind. This is not part of the Terraform, it's a part of the cloud perspective. Currently, in earlier cases, we are using access key and secret key for any kind of involvement connecting to the service API call and all. Now, every organization pushing the two-factor authentication with like a authenticator code generation. In this case, anyone facing that issue for like a kind of automation in the CI/CD pipeline perspective, anyone facing that issue for creating the resources, like uploading the files to the ECR or uploading the images to ECR or any interaction, anything while doing the automation? This is not the question for Terraform, it's general cloud perspective. The reason why I'm asking that, currently we are facing continuous pipeline perspective. We are uploading the images to ECR, like a cloud Elastic Cloud repository. For that, it is asking the multi-factor authentication code. So is it possible, or any approach, anyone in the group already done some kind of challenges? Maybe you can share that experience. It would be easy for us, helpful for us.
Last, if you remember, we had done something like some calls to the Active Directory, something similar to this for a particular customer, right? So maybe you could suggest some solutions there, having some own custom scripts, maybe some Python or Ruby, which could be used to fix this.
Oh, that's good.
I'm sorry, in that case, could you please repeat the question?
Lars, actually, we are facing the issue when developing the end-to-end pipeline for building the code and compiling and building the code, creating the image. After creating image, we need to push the image to ECR. After pushing the images, the Kubernetes cluster, we need to pull the images. For that pushing the images and pulling the images, always asking the multi-factor authentication session key, STS token. So STS token not only for a secret key and a secret access key, along with us, we need to provide the session token from the mobile. Maybe we installed some apps for multi-factor authentication perspective. So in this way, we are struggling to do automated that steps.
At this time, I'm sorry, but I can't give you a reply right away. But if it's fine for you, I can have a look at this after this meetup, and I can give you an answer after that.
Yes, sure. I will, if you record, I will give some explanation more in detail over the mail.
That would be nice, yes.
Yeah.
If there aren't any more questions, then I think we can come to an end. So yes, please, we would also like to ask back on, for example, what we could improve for our next time, what you liked, what you didn't like, and also, for example, if you would be interested in maybe even some more advanced talks about Terraform, for example, on how to include other tools that bring you some quality of life stuff, for example, TerraGrant, or also including Sentinel in your toolchain and stuff like that. So yes. Also feel free to give us some feedback on the Meetup platform. And thanks again for joining us.
Thank you very much for a wonderful opportunity, Lars and Sunny. We will be good. We can continue for the same in the coming days.
Awesome. Then I wish you all a very nice evening, or depending on your time zone, a nice day, a nice morning. And I hope we will see you soon.
Yep.
Thank you all.
Bye.
Thanks a lot. Bye, everyone.
Bye.
Thank you, guys. Bye.